Do I need? Okay, well, thank you very much to people who are here this evening or online. Um, this talk is roughly in sort of three parts. There is a little bit of a historical review, not comprehensive in any way. Then we're going to look about what was found by the M6 toll date, which is now 25 years old, but it is still worth reviewing. And then finally, looking at what was found with some of the HS2 data, which is frustrating. It's a little bit like having a jigsaw puzzle and only half the pieces. So you'll see what I mean as I carry on. So basically, the notion that glacial ice had once covered Great Britain was generally accepted by the scientific community by the 19th century. The deposits left by the former glaciers were not the results of Noah's flood, as some people thought. Now, observations by the Geological Survey and others at the end of the 19th century are able to divide the deposits into newer and older drifts on the basis of relatively fresh landforms left by the most recent Devensian glacial period. The extent of the Devensian ice into the West Midlands was reasonably well defined by mid-20th century geologists. I say, after an initial advance of ice as far as Wolverhampton, hence the Wolverhampton line, the ice margin then pulled back to the middle of the Shropshire-Cheshire plain, where substantial end moraines were deposited, and that's the Wrexham Barhill moraine. And the most recent BGS classification of the Neogene and Quaternary deposits, the deposits of the initial advance were classified as a Brewood till formation, and the deposits of the standstill phase were classified as a Stockport formation. And this distinction was recognised and used in the classification of the superficial deposits encountered by the HS2 Phase 2A. However, a word of caution. The limit of the last glaciation may at first sight seem to be a topic which holds little potential for study, because the limit is relatively ungeologically and therefore may be thought to be self-evident. There are several reasons why we should not accept uncritically the limit as currently defined. We cannot be sure that the limit has been mapped correctly. The position is everywhere an inferred position, and the evidence in most places leaves a considerable margin of error or zone of uncertainty. In some cases, error has been introduced by the interpretation of features as marking the position of a terminal moraine feature, and further observations demonstrate that this is incorrect. So basically, in talking about the Devensian ice margin, I'm actually going into a minefield where there is quite a lot of uncertainty. However, Morgan in 1973, in his seminal work, did identify the Wolverhampton line, but only for a relatively short section in the Wolverhampton area. But as you can see that it is quite a bit further south from the Wrexham Barhill moraine, which is the second phase of the Devensian ice age story. And Morgan was able to deliver it for a short period, but he also highlighted the importance of the Four Ashes site. This is now the type locality for the Devensian cold stage, but I don't think there's much visible today. But what's notable at the Four Ashes site is the intense periglacial disturbance of the Irish Sea Till, which is a Brewood till formation. And I shall say more about this towards the end of the talk, because that's quite a relevant observation. So the Devensian ice limit was depicted on the 1977 BGS 625,000 quaternary geological map. That should be the end of the story, but more recent publications, including the Brit Ice project, is much less definitive. And I got a question, why? So we've got some information about the Wolverhampton line going west into Shropshire, and that's from the 167 memoir from 1947. Note that it depicts the approximate limits of large Irish erratics, not the ice margin. So it's going back to this guy who was showing that it's not as clear cut as you might think. However, this is where you do get some definitive data. The M6 toll alignment was expected to cross the Devensian ice margin near Chasewater based upon the BGS 1977 map, and to give some confirmation on the BGS model. The data from the boreholes was instructive. The Devensian glacial deposits formed a continuous layer of glacial till-stroke dimicton and glacial fluvial deposits about 10 meters thick to the south of Chasewater. These deposits were observed to finish close to the location of the Sherwood sandstone quarry at Wharf Lane. And as its location, just to the east of Chasewater, superimposed upon the superficial deposits from the Geology of Britain viewer, which don't really tell you very much at all. However, the Wharf Lane quarry showed Brewood Till Formation glacial-fluvial deposits, probably proximal, overlain by Brewood Till Formation glacial till dimictum. And this may be a terminal moraine. However, this key location was destroyed when the M6 toll was built, but a small section remains at the back of a depot north of the highway. So what I would say is the Wharf Lane quarry on its own is not definitive, but the Wharf Lane quarry, together with the results of the boreholes of the M6 toll, does make a story. And the fact that the Devensian ice margin, the Devensian deposits stop at that point, does give a good clue, a good idea that that was a Devensian ice margin. There is now another bit of data I'm going to add, which kind of compounds or adds to that story. And this is from a site in Brown Hills and results of some trial pits and boreholes. And I'd like to make specific attention to trial pit 23, which is to the west of the eastern boundary fault and is underlain by coal measures material. And this is what was recorded in that trial pit. They described dense orange-brown, slightly clayey, fine to coarse, rounded sand and gravel with occasional cobbles, becoming clayey, glacial sand and gravel, Triassic derived. So the Triassic derived till occurred at a location to the west of the eastern boundary fault, suggesting derivation from the east or northeast. Whereas the M6 toll data was showing that the deposits were coming from the west or northwest, and between those two locations, you could say that that is where the Devensian ice margin is. So you have the Wharf Lane quarry, and then you have the information from the site in Brown Hills. And this location is very similar to that depicted on the BGS 1977 map. So where you can sort of say that's the Devensian ice margin, it does give some credibility to what the BGS thought. Now, I also want to talk about some of the older glacier deposits, which the M6 toll found. That the data showed older deposits, possibly of Wolstonian age. I don't want to get into controversy about that tonight. They have a different character from the Devensian deposits. The older deposits are much thicker in places, have an irregular base, and contain deposits of a glacial equestrian aspect, which are depicted in red on this section. Boreholes for the I-54 site north of Wolverhampton showed a thin and in places discontinuous cover of Brewood Till Formation. And this to some extent was what we found on HS2 as well. So it does appear that the Brewood Till Formation deposits are thin, whereas the thick glacial deposits to the west of Walsall might also be older. If you look on the geological map, you'll see there's a large area of glacial deposits to the west of Walsall, and there's a little bit of information suggesting those deposits are quite thick. Whereas what we're suggesting here is the Brewood Till Formation is generally thin, in places discontinuous. So it's possible that in the area west of Walsall, only the top 10 metres might be Devensian. The rest of the thickness of glacial material there might be of an older glacial deposit. I have no data on this, but using the M6 toll and the Palsall Road template, it ought to be possible to distinguish in GI data between the two ages of glacial deposits in the area west of Walsall. However, detail might be beyond what a routine GI contractor would be able to resolve. The BGS might have a view on this, but from the remapping of the Litchfield sheet, but this information is unpublished, I think. So you say the older glacial deposits, you might think might have some flint in it. That's one of the possible diagnostic features of the older glacial deposits. But the fact is that where you have the glacial ice margin, it's between Chasewater and Walsall and Wolverhampton, there is this indication that there are two ages of glacial deposits present. So the Wolf Lane location, which I have just described, which I think putting together the what you can visually see or could see in the Wolf Lane quarry plus the M6 toll data, does actually correspond very closely with the BGS geological map. And I say that I don't really can see on there that is the location just there. And then the line goes further to the northeast towards Yoxall, where there is a possibility that the BGS might have seen a moraine. But this is controversial, as many recent publications, including the Brit Ice project, would dispute this. I also add that other sources, such as the remapping of the National Forest project, suggest that the Brewood Till extends across much of the Needwood Forest. So there's quite a bit of uncertainty as to how far the Brewood Till formation got along the Trent Valley, beyond the point where you could see at Chasewater there was a reasonably definitive margin. So what I'm going to do now is spend a little bit of time looking at what the BGS observed on the sheet memoir for sheet 140. I'm going to talk through this in some detail because to some extent this is still probably the best information we have on how far the Devensian ice, the Brewood Till formation, actually extended along the Trent Valley. So I'm going to basically just go through this point by point, but basically the late Irish Sea drift west of the great sort of great sweep of gravels at Appens Bromley. So this is talking about this area here. So west of the great sweep of gravels at Appens Bromley, there are scattered patches of boulder clay and gravel, and also, more significantly, a number of excellent overflow channels, which are not found in the area to the east. This is what the BGS think. It seems certain that Irish sea ice banked up from the west against Cannock Chase, broke through into the area of the Trent drainage and deposited boulder clay and gravels in a district around Great Haywood and Hixton. Around Hamsall Ridgeway and Yoxall, the gravelly character of the drift, rich in quartzite pebbles, suggests the Irish Sea may even have reached as far as these villages. I'm talking about this area here. And indeed, in one of the few cases where the drift has the appearance of a moraine at Brankley, This is the location used on the 1977 BGS map to define the Devensian ice limit, as it's only 4 kilometres northeast of the M6 toll limit. That the Irish sea ice penetrated into the valley of the River Soar in some force is evident from the excellent series of overflow channels which cut across the northern slopes of Cannock Chase, sort of in this area here. The southernmost of this series is a conspicuous overflow channel now containing Rising Brook, which starts about 510 feet at Hensford, southwest of Rugeley, and extends by way of Moors Gorse to a point about 1.5 miles southwest of Rugeley. And this is this area here. As I say, 2 further channels occur at the northern end of Cannock Chase. One starts just south of Oat Hill, running nearly due east to Seven Springs, northwest of Hayward Park, and further to the north, close to the main road from Stafford to Rugeley, a similar channel runs northeast into Shugborough Park. On the northern side of this lobe of ice, marginal drainage channels were developed a short distance at Knoll Farm area, and Lee Heath, a mile southeast of Hixton. There may be some moranic onygens formed, sort of deposits of moranic onygens formed by the retreat of this ice. The presence of a mass of sand and gravel showing an ice contact slope northeast of Park House, west of Ettingshall, shows that the ice lobe either overrode or flowed round the northeastern corner of Cannock Chase. And a granite erratic noted by the Geological Survey in that location there is consistent with this. And then finally, between Stowe and Amerton, the boulder clay descends into the Trent Valley, and the ice appears to block the valley, which now contains the Amerton Brook, causing the formation of a lake whose waters cut to overflow channels across the watershed and into the Blythe Valley. So there is quite a lot of information from these observations from the Geological Survey about ice getting into the Trent Valley to the north of Chasewater. So we have evidence from the BGS of the ice coming to the northeast of Cannock Chase. And we have the information from the M6 toll showing ice coming from the east and the Devensian ice margin shown in red. And it is notable that on the old geological map, deposits associated with the lobe of ice coming in from the west across the M6 toll data does seem to be rather better defined than what you might see on the Geology of Britain viewer. So I think this reflects uncertainty in interpretation. The HS2 Phase 2 alignment crosses this area, and it should give some answers. So the information, the area covered by HS2 is depicted on the 2 ages of geological map. There's the 1 to 50,000 from the 1940s from sheet 140, and the old Litchfield sheet 154. The data there is really quite old, from the beginning of the 20th century. And that shows that you have recent alluvium of the River Trent, then you have a number 1 river terrace, and then you have older river gravels. And on the Geology of Britain viewer, reflecting the resurvey, we see that the number 1 river terrace is now classified, called the Holme Pierpoint member. And then the older river gravels, they have equated that with the Beeston member. In the final, slide there, that I do introduce some of the nomenclature of the river terraces associated with the River Trent. So the old names of Beeston Terrace and Hilton Terrace have now been replaced by a whole series of members. So you have the Beeston member, which is reckoned to be early Devensian or Ipswichian. And then the status of some of these older members, which relates to Hilton Terrace, I would say is another topic, and possibly even a PhD. The nomenclature and the age is uncertain, as I suggest here, that it will make more sense if the last glaciation into the Trent Valley beyond the Devensian ice margin was of Wolstonian age rather than Anglian. And say the BGS court, there's some material here. If you look on the Geology of Britain viewer in this area here, they say those are glacial-fluvial sheet deposits belonging to Trent Valley Formation, but the member's not defined on the Geology of Britain viewer if you go in and have a look. And this suggests uncertainty. There is uncertainty on the age of the older glacial deposits in the Trent Valley. So there's uncertainty as how far the Devensian ice got, and there's uncertainty as to what the age of the older glacial deposits in the Trent Valley is. And I say that I don't want to go into too much about trying to unravel the older glacial deposits, other to note that they do occur and there's an overlap between the Devensian and the older. So what did the HS2 find? This is where things get a little bit more interesting. Firstly, along the HS2 corridor, a single river terrace appeared to be present across the whole of the valley bottom, which isn't what the geological maps would suggest. You would expect to go onto the older glacial deposits, older river gravels. The HS2 data could not distinguish between the number 1 terrace, the whole Pierpoint member, and the older river gravels, the Beeston member. And the Beeston member was probably not present on the HS2 alignment. However, just the southwest of the HS2 corridor, a thinner and discontinuous gravelly deposit is present, which just extends into the HS2 corridor, where possible glacial deposits were noted. And just in this area here, where it's annotated, possible glacial deposits, that is shown sort of possibly underlying the river terrace material. And then you get to a certain point, you get the older Trent Valley deposits, which are probably of Wolstonian glacial fluvial origin, but it does need further review. The other thing we found, which was a bit unexpected, was the whole Pierpoint member has a narrow incised channel up to 18 meters deep. And so this was unexpected. There's a paleo-channel in there. The extent of the alluvial deposits, the Hemmington member, corresponded with the older published geological maps and does not correspond with the Geology of Britain viewer information, which suggests alluvial deposits associated with the River Trent have a much wider distribution. That is not correct. The other thing of note was that the weathering profile in the Mersey mudstone does not follow the base of the Holm Pierpoint member, suggesting that this weathering profile predates the Devensian erosion of the Trent Valley. And I say that I don't think you can see there's a whole line of question marks going across beneath the Trent Valley. When you get to the point where you have the incised channel, that weathering profile continues across without any perturbation. So finally, there is no clear evidence of an advance of Brewood Formation ice across the area from this HS2 data. Some glacial deposits were noted, but it is unclear whether these were Devensian, i.e. Brewood, or earlier. So let's say we have about 50% of the jigsaw pieces for this area, and the actual final picture is not all that clear. So I now want to talk about the paleo-channels, because this is one of the results of the HS2 data, which was a little bit surprising, that basically the incised channel, and it could relate to the Brewood Till Formation ice advance into the Trent Valley and across to Yoxall. However, in the HS2 Phase 2 GI, the gravels infilling the channel could not be separated from the overlying river terrace deposit. This does not mean the incision place is not Brewood, but the channel infilling and the lateral extent of the Lake Devensian river test braid plain were perhaps a continuous aggradation in response to continuous sediment and meltwater input from the Irish Sea to the northwest, especially during the Stockport standstill. Below the River Trent confluence at Burton-on-Trent, the Hornpill Terrace is still thick, about 7.5 to 8 metres, but there's no evidence of an incised Devensian channel, whereas once you get up the Trent towards Rugeley, there is some evidence of an incised Devensian Paleo-channel. However, at Burton-on-Trent, an incised channel from an earlier, possibly Waldstonian glacial phase does exist. It's a continuation of the Stretton Paleo-channel, and this gravel infilled Paleo-channel contributes significantly to the groundwater resource used by the brewing industry. So there's a little bit of local knowledge about the Burton beers. The Devensian incised channel did extend beyond the Rugeley area, up as far as the Trent confluence, but it was only about 14 metres deep rather than about 18. So the incised channel exists, and incised channels, tunnel valleys associated with the Brewood phase are present in the Stafford area, but they're difficult to distinguish from the Stockport phase when copious meltwater crossed the area. Now, going back to the Paleo-channel information now, because this is where things do get interesting. So talk about the fact that you have the Stretton Paleo-channel, and that it can then be traced all the way through Burton-on-Trent. And I say that there's a possibility that this Paleo-channel extends beneath Burton-Trent and possibly beyond as far as the Tame-Trent confluence, and perhaps even along the Trent Valley as far as the HS2 corridor. And this may be of Waldstonian age. Several boreholes on the HS2 corridor beneath the central part of the Trent Valley encountered anomalies, which at one location did seem to be a glacial deposit. And I'm just going to read the descriptions out of the borehole log, which encountered glacial material. So you had river terrace material from 7 to 9 metres, and then at 9.3 to 10.7, you had a firm, round, thinly to thickly laminated, slightly sandy clay. Sand is fine. That sounds like a glacial lacustrine deposit, and we have seen glacial lacustrine deposits in some of the older glacial deposits. Beneath that, you had stiff, reddish-brown, slightly gravelly, slightly sandy clay. Gravel comprises sub-rounded, fine siltstone and quartzite fragments. Sand is fine. Not sure whether anybody saw any flint in that. And that deposit carries on down to 12.49 metres, where you then had soft, reddish-brown, slightly gravelly, slightly sandy clay, which is basically worked Mercia mudstone, and then you go into weathered Mercia mudstone. And then only at a depth of 2.29 metres beneath the base of those glacial deposits do you get the gypsum coming into the Mercia mudstone, showing you're getting well down into the weathering profile. So the weathering profile of the Mercia mudstone here is very thin. So the excess thickness of superficial deposits in this area are also reported by historic NCB boreholes adjacent to the HS2 corridor. And I just put in the information from the BGS geoindex of SK 11 Northwest 13, which purports to have nearly 50 metres of gravelly drift in it. Unfortunately, another key historical borehole, 11 Northwest 12, which is quite close to the HS2 corridor, none of the HS2 boreholes it could confirm that was a significant thickness of superficial deposits. And so there was a possibility that the significant thickness of superficial deposits in SK11 Northwest 12 was incorrect. And that really reflects that those NCB boreholes were basically dumping cutting samples. So they had somebody looking at the arisings as they sort of open hole that section. They're not definitive, but there's a lot of question mark anomalies. I say they've got 50% of the jigsaw pieces here, but we do have one borehole which describes laminated glacial lacustrine material beneath the river terrace deposits. One or two other boreholes in the area did also show anomalies. So you'd have apparently a few meters of apparently intact Mersey mudstone. Then it went back into gravel again. But in all those instances, there's always a slight question mark about the drillers, whether the casing was actually down onto the top of the Mersey mudstone. And you couldn't be 100% certain that these accounts of gravel were kosher or not. But they did keep on cropping up. They weren't a sort of one-off thing. But we do have one location where there is definite glacial deposits. But as I say, one swallow doesn't make a summer, and could really do with some more data. So the data basically makes it more difficult to assign the possible glacier deposits on the sort of south side of the Trent Valley to the Devensian. Right, I think we're probably getting towards a conclusion on this. Talking about paleo-channels, there are several paleo-channels associated with the Brewood phase, and they occur very much in the Stafford area. So the Doxy channel, for instance, was encountered by boreholes for the M6. The channel noted by Morgan in 1973 was encountered by boreholes for the M6 toll just south of Cannock. This record, in a sense, is sort of complicated by meltwater channels from the Stockport phase. So we have the paleo channels of Brewood age. Those channels also got reused by meltwater during the Stockport phase. However, the M6 toll location isn't near a Stockport meltwater channel. And also the boreholes did show that it had been showed several phases of incision and filling up. So the channel, paleo channel at Cannock, which is a Brewood age, is quite complex. It's not a single incision and aggradation. So that's a bit of a story about the Devensian paleo channels. You have the Brewood phase, then you have the Stockport phase, and the Stockport phase is really quite substantial. So in some places, we found that the channels associated, or the glacial deposits associated with the Stockport phase, are up to 20 meters deep in the valley, in some of the valleys to north of Stafford. So the overlap between the Stockport and the Brewood is not clear cut, but at the location on the M6 toll, there is no Stockport paleo channel there. Therefore, as indicated by Morgan, that is likely to be a Brewood paleo channel. Let's say there are features relating to the Wolverhampton line, again, that some do exist, as noted by Morgan. So that he obviously could see something in the landscape which he assigned to the retreat of the Brewood ice margin. And I say the channel is part of that. There's also an esker which he recognised. I'll be really interested to know what the British Geological Survey think of this data today, whether they feel that this is still valid. But it's just an observation that there are some features relating to the Wolverhampton line, but generally speaking, they don't seem to be very well defined. Now, there is a possible reason for this, that with the HS2 Phase 2A data covered an area to the east, north and northwest of Stafford, which is an area affected by the Brewood Phase Wolverhampton line ice sheet. The data showed a discontinuous and intensely periglacially disturbed covering of Devensian glacial deposits. It is indicated that after the retreat of the Brewood Phase glacier, during the Stockport phase, when ice still occupied the Cheshire Plain, rigorous periglacial conditions existed to the southeast of the ice margin, which then eroded and reworked the superficial deposits left by the Brewood Phase. And this included any terminal moraine features that might have been left by the Brewood Advance. I say there are some retreat features noted. And the other feature which is probably worth noting is that the unconsolidated superficial deposits left by the Brewood Advance were being very susceptible to periglacial reworking and disturbance. We noted this in the landscape left after the retreat of the Stockport Glacier. This is towards the south of Crewe, where the Stockport glacial deposits had also experienced intense periglacial reworking. And again, those unconsolidated superficial deposits left by the glacier then got reworked again. And this is evident, the periglacial reworking is evident in the Brewood Phase deposits at the Four Ashes site, where you can see really significant prior-turbation convolutions generated by this intense periglacial phase, which has affected the Brewood formation glacial deposits, which is why they are thin, discontinuous, and in some instances very difficult to distinguish from a periglacial layer itself. So, some conclusions. The limit of the Devensian ice to the northeast of Wolverhampton, apart from the M6 toll data, remains poorly defined. Short-lived lobes of ice advance along the Trent Valley to the northeast of Cannock Chase and to the south of Cannock Chase, but doesn't look as if the ice actually completely overrode Cannock Chase. The HS2 data has not clarified the matter. Where the alignment corridor crosses the Trent Valley, southwest of Kings Bromley, there is some evidence of older glacial deposits, but no clear imprint from the Brewood Phase, apart from the incised Paleo-channel at the base of the Holme Pierpoint member of the Trent Valley Formation. So again, this is a subject for discussion and argument, or perhaps even a PhD. After the retreat of the Brewood Phase, there was a prolonged period of intense periglacial degradation of the landscape and reworking of the Brewood glacier deposits. And this appears to degraded features related to the Wolverhampton line advance, which is why the occurrence of the erratics is as definitive as anything. But you do have the M6 toll data, you have Wharf Lane, the M6 boreholes. There's a story there. You can put your golden spike in there, but you can't do that in very many other places. Thank you very much.